Chapter 5b, Day 3, Graphing Quadratic Inequalities. Inequalities, when it comes to inequalities, we use the shading to represent which region represent the solutions. So take a look at example number 1. f of x less or equal than x squared minus 4x plus 3. So we just discussed this in 5a. If you are not familiar with this, or if you forget already, make sure you revisit them. You guys just took the chapter test 5a, so it should still stay with you. 5. f of x equals less or equal than f of x less or equal than x squared minus 4x plus 3. What's the axis of symmetry? So you can either use the completing square method to rewrite into vertex form, or if you remember the formula that I gave you on day 1 of section A, x equals negative b over 2a. Either way, you should get x equal to positive 2. So use the complete square method or the formula x equals negative b over 2a to find the axis of symmetries. How about vertex? If you know the coordinate for your vertex, then you can plug it in and calculate the y. Or if you already did the completing the square, rewriting into vertex form, then you should have f of x equals x minus 2 squared minus 1, which gives us the vertex location at 2, negative 1. X-intercept. So I've been reminding you this no less than 10 times by now. X-intercept by setting the function, given function equal to 0 to make that into an equation and then solve for your x. So this particular case, I can use the factoring method. X minus 3 times x minus 1 equals 0. So my x-intercept is going to be 3, 0. 1, 0. 2 points for the x-intercept. How about y-intercept? Y-intercept is by plugging in x equals 0. X equals 0, plug it in, 0 minus 4 times 0 plus 3. So y-intercept is going to be 0, 3. Is this going to be a solid line or dotted line? So this is going to be the same as we discussed in linear equation case. If you see the equal sign, if there's the equal sign, then definitely it's going to be solid. If you don't see the equal sign, it's going to be dotted. So since we see the equal sign with a given function, it will be solid. So graph your quadratic equations according to all the information we have. Axis of symmetry is going to be located at x equal to 2. So I draw as a dashed black line. For the quadratic equation, and for the vertex, it's located at 2, 0. For the x-intercept is 1, 0, 3, 0. And then y-intercept is 0, 3. With all this information, you can go ahead and graph your quadratic equations. Which region do you shade? So this comes down to the inequality part. Which region do you shade? So like with any of the linear equation case, I like to plug it in 0, 0. So what I mean is, if you plug it in 0, y equals 0, plug it in and test, is this statement true or false? 0 squared minus 4 times 0 plus 3. Is this statement true or false? Is 0 less or equal than 3? Yes, it is true. So as I see that the 0 is outside of the quadratic equation, then I'm going to shade in the regions outside of the quadratic equation part. And that's how I decide. I use the testing point 0, 0, and 0, 0 is outside of the quadratic. So if one test point satisfies the equation, and then the rest of the points should satisfy as well. So I just use one test point to test it. Number 2, f of x greater than. So this time there's no equal sign. So I should immediately circle down. It's going to be dotted line for the border line. So just like the previous example, I like to rewrite the quadratic equation into vertex form. So using the completing square method. Again, if you're not familiar with completing square, make sure you revisit. All we have to do is make sure the leading coefficient equals 1, and then take the linear term coefficient divided by 2, then square it. That's the number you are going to add. If you add a number, then you subtract the number if you subtract a number, then you add a number. That's called completing the square. Or if you use the formula to find the axis of symmetry, ax equals negative b over 2a. Both ways you should arrive at. The axis of symmetry is going to be negative 3, vertex is negative 3 and 4. X-intercept is going to be, again, set your functions equal to 0. Solve for the x values. So x-intercept, I have negative 1, 0, negative 5, 0. Y-intercept is located at 0, negative 5. So y-intercept is by plugging in x equal to 0, and which happens to be the constant. And because our leading coefficient is negative 1, so it's going to be an opening down parabola. So with all the information above, we can put it in to plot the graph. Don't forget it's going to be dotted line for the border line. Last part, test your 0 point. So again, ask yourself, is 0 greater than negative 0 squared minus 6 times 0 plus 5? Is this statement true? Is 0 greater than 5? Is this statement true or false? 0 minus, the constant should be negative 5, not plus 5, negative 5. Is 0 greater than negative 5? Yes, obviously it is. So we know we are going to shade it in the region that has the 0, 0 in it. We are going to shade it in the region that has 0, 0 in it because it passed the test. Number 3, the last one. Oh, look at this. This one is already in vertex form, so that should give us the information right away. Axis of symmetry, x plus 1 equals 0, so set that equal to 0. I have x plus 1 equals 0, x should be negative 1, and that's our axis of symmetry. Vertex is negative 1, negative 4. X-intercept, again, set to function equal to 0, solve for the x. So x is going to be 1, 0, negative 3, 0. Y-intercept, this time you will have to plug in and calculate. This is no longer as the standard form, so make sure you calculate. 0 plus 1, that's 1. 1 squared is 1. 1 minus 4 is negative 3. So make sure you calculate your y-intercept. And I do see the equal sign, so this is going to be a solid borderline, solid. Which region do you shade? Again, use the testing point 0, 0. Is 0 greater or equal than 0 plus 1 squared minus 4? Is 0 greater or equal than, so 0 plus 1, which is 1, 1 squared is 1, 1 minus 4 is negative 3. So obviously 0 is greater or equal than negative 3. So we are going to shade in the region that has 0, 0 in it, and which happens to be inside the quadratic equations. And this is the part of quadratic inequalities.